Hi, today we're solving Leetcode number 144, binary tree preorder traversal. And basically, we are given a root node of a binary tree, and we're supposed to traverse it using the preorder method. And this is an easy problem, and the only hiccup for this particular problem is just the fact that in the follow-up, they ask us to solve it iteratively as opposed to solving it recursively. And that's what the solution we're actually going to be showing today. So basically, when you have the root node, in this case the root node here is 1, and you are trying to traverse it by using the preorder method, it means that you're going to be getting the leftmost number, or the leftmost property, or leftmost node rather, on the binary tree until you can't go any left, then you go right. So for instance, here we have 1, and then the leftmost part of 1 is null, it's pointing to null since there's no other number there. And then we have 2 by the right, and then 2 on the left has 3, but on the right it has null. So if there's no number attached to it, we can just assume that the next number there is null, right? So in this particular case, first of all, we print the root node at this point, which is 1. That's correct. And then after printing the root node, we try to print the leftmost node. At this point, leftmost node is null, so we don't print that, right? So we move to the rightmost one instead, and we print the rightmost node, which is now currently the root. So we print 2. And then after printing 2, we're supposed to print the leftmost node at this point, and at this point that's 3, so we print 3. And because 3 at this point does not have like a leftmost node, and it also does not have like a rightmost node, so we move back to 2, and 2 also does not have like a rightmost node as well. So that's it, it ends there. So that's basically it. If we don't have like a node, we're just supposed to return like an empty array as well. So let's actually get on to solving this. For the solution I'm proposing, we're going to use a stack, right? So let's assume that this is actually the question, the problem we're trying to solve by this example right here. And for the root node, of course, we have 1. And then in our stack, we start with 1, obviously. Now, when we get the value at the root node, right, we get the rightmost value first. And when we get the rightmost value, we take this value out of the stack and replace it with the value in the rightmost part. Why we're going to start with the rightmost before the leftmost is because when we're going to be taking it out of the stack, we want to get the left first before we get the right? So we take null in this instance, and then we put in null in this instance, and then the next one is going to be 2, right? Now that we have 2 and null, of course, in our output we're going to have 1 already saved there, right? Now when we pop off this next value, at this point the next value is going to be 2. So when we take off 2, we have 2 here, right? Now we have to replace this 2 that we've taken now with the rightmost value. Now at this point 2 does not have any rightmost value, so the 2 is just going to be null, right? And then we have the leftmost, then we try to get the leftmost value of it, that's this dot left of this particular node, so which is at this point is 3. So now that we're done with this, we can just put this 2 in our output as well. Now that we've done that, we don't have any remaining value, so we'll go back into our stack, right? Now going back into our stack, we get the last value at this point, which is 3. Now when we get 3, we check if it has rightmost value, it does not have rightmost value. Check if it has left value, it does not have left value. So we just put 3 inside there. And since it let's actually get to solving it. I think that when you actually see me try to implement it, you understand a little bit more what I'm trying to say. So we have preorder traversal. At first, we're going to declare our variables, of course, which is going to be output, which we're going to keep as an empty array. And then what are we going to return at the end? At the end, we want to return output. Then we want to check for some things. For instance, for like instances where we don't have anything in the root, right? We just want to return empty array, right? Now we're going to, of course, I forgot that we said we are going to use a stack, so stack is going to be here, it's going to be the array. Now, because of the fact that we're using a stack to represent this, it means that our space complexity is going to be O of n, because in most case, every single value in this tree is going to go into the stack, right? And then our time complexity is going to be O of n as well, because we're going to run through every single item in the tree, right? So like we said earlier, we're going to be starting with the roots. Now, as far as the stack dot length is greater than 0, we just want this stuff to keep running, right? So that's basically, so what we'll be doing here in the first place is that we're going to declare the node, which is just going to be when we pop off the stack. So we're going to take the last 10 out of the stack at every point, and then when we take this off, we just have to check if this node, that's if it's not null, right? If it's not null, then we just push the value inside output here. Push node dot value, and then when we're done with that, of course, we want to, when we're done with that, like I said, we're going to take the leftmost value. First of all, we'll take the rightmost value, right, and push it into the stack. So we're going to push in node right, and then we're then going to push in node left, so that when we are popping, we get the left first before we get the right. Hope that makes sense. Node dot left. And that's it. That's our solution to this problem. Let's run this. Oh, I'm so sorry. We are doing stack dot push, not node dot push. Stack dot push. Yeah, we are pushing the value in the node. Let's run that again. Yep. And then now we can submit our solution, and yeah, that's it. And because of the fact that we're using a stack, our memory didn't do so well, but our runtime is better than 96% of the submissions. So yeah, that's how you solve that. Please don't forget to like and subscribe, and come back soon. Bye.